Okay, so the last topic in this unit is the mole. Okay? The mole is a unit that we use in chemistry, and it measures or represents a number of particles. Okay, so the mole works just like a dozen. How many are in a dozen? 12. We all know that. A dozen is just a representative word for the number 12. Okay, a mole, I don't know why they chose the mole, but they chose mole, is a representative number for this. Seriously, that's 602 with 21 zeros behind it. It's a lot. Okay? That is the number of particles in one mole. Okay? One mole can be of anything, just like a dozen can be of anything. I can have a dozen eggs, a dozen donuts. Okay? I can have a dozen sausages, whatever. Okay? I can just have a dozen, always means 12. It doesn't matter what I'm talking about. I know that a dozen means I have 12 of whatever it is. Okay? The same is true of a mole. If I have 1 mole of gold, I have 6.02 times 10 to the 23 atoms of gold. Okay? If I have 1 mole of water, I have 6.02 times 10 to the 23 molecules of water. Okay? Whatever the smallest unit of the thing I'm dealing with is, I have 6.02 times 10 to the 23 of that. Does that sort of make sense to everybody? Okay? So a mole is a representative number. Now, it may seem like kind of a random number, okay? And it looks that way when you just look at it, but it actually is the result of a lot of experimentation to arrive at this. Okay? Basically what happened is someone wanted to come up with a representative unit because it's obviously impossible to count atoms. We can't see them. They're very small, and even an incredibly small amount of something is going to have an incredibly uncountable number of atoms in it. Everyone kind of follow me there? So we wanted to come up with some kind of representative number for a certain amount of something. So what they did is they used hydrogen. Okay? Hydrogen is the simplest atom there is. It's 1 proton, 1 electron. That's it. Okay? Very, very simple. So it would be very easy to calculate, let's say, how many atoms of it would be in a certain amount, like a certain mass. For example, 1 gram. So if I had 1 gram of hydrogen, I could figure out how many atoms there were because we know the mass of a proton and we know the mass of an electron. Okay? And so when they did the calculations, they found out that in 1 gram of hydrogen, there are 6.02 times 10 to the 23 atoms of hydrogen. Right with me there. Okay. Now, they did the same thing with everything on the periodic table from there. Okay? They took that number and they figured out what the mass of every single element would be for that many atoms. Right? So that's what these numbers here, the atomic masses, are. Okay? They are the mass of this many atoms of that material. Okay? Everyone follow there? No? Okay, where did we go?
Part about the mass responding to that many.
Okay, so let me go back. What they did is they took 1 gram of hydrogen and they figured out how many atoms of hydrogen would be in that 1 gram. Because an atom of hydrogen is an easily calculable mass, right? 1 proton, 1 electron. They found out it's this many. Then they said, okay, this is going to be our representative number for everything. So then what they did is they took certain amounts of other materials and kind of figured out what their molar mass and what the mass of this much would be. Does that make more sense? Okay. So we're going to look at the relationship between moles, mass, and molar mass. That's kind of a little bit more of this kind of but mathematical. Okay? And then we'll use the mole equation to solve problems. Okay? There's basically only 4 ways I can ask you a mole equation problem. Okay? It is, however, going to involve you doing some algebra. Okay? Algebra is easy, regardless of what you may have been unintentionally told. That's the way I'm going to say it. Okay? I know there are some very well-meaning science teachers out there who are afraid of math, And as a result, they teach shortcuts on how to manipulate formulas. I'm going to teach you how to manipulate formulas, period. Okay? I'm not going to teach you any tricks, because it isn't that hard to learn how to do it properly. Okay? So we're going to go over that as well, because the little tricks that you've been taught, they don't work past a 3-variable formula. Okay? So we're going to be looking at how you can use these rules to solve anything. Okay? But first, let's talk about the mole. Okay? So we can express the amount of a substance in a number of ways. We can use grams, which would be telling people the mass of the material. Okay? Or we could tell people the volume of material. We could say how many cubic centimeters or how many liters of that material we have. Or we can tell them how many moles we have. Okay? And if we say we have 3 moles, then we know we have 3 times that number. Right? We have 3 times that number of something, because this is the number of anything in 1 mole. In 1 mole. Okay? So this is like 12 is to a dozen. This is to a mole. Okay? So if I have 3 moles of something, I have 3 times that number of particles of that material. Okay? All right. So we can't possibly, like we said, count particles, so we use a representative number, in this case the mole, and because we're very busy, we abbreviate it. 1 mole. Wow. Okay, you say that like you haven't seen somebody do that before. Okay, we have an abbreviation for at. It's that. Okay, we're busy. Right? So we abbreviated MOL. So, like we were saying here, okay, the 6.02 times 10 to the 23 is just like a dozen. Okay, 12 is always a dozen. 6.02 times 10 to the 23 is always a mole. If I have 3 dozen of something, how many do I have? 36. Okay, and if I have 3 moles, I have 3 times this number. Okay, just works exactly the same. All right. So this number here is Avogadro's number, because he's the guy who did all the experimentation and arrived at it. Okay, now, when I show you a picture of Avogadro in a few slides, you may figure out why he used the word mole as his representation. No, he doesn't have, it's not like in Austin Powers, he doesn't have a big is there a pedal? Okay, but he looks kind of I think it's just the cut of his suit, but it kind of. All right. Okay, so the mass of 1 mole of a substance is known as the substance's molar mass. Okay, when we're talking about elements, we call it atomic mass, but really it's molar mass. It's the mass of 1 mole, 6.02 times 10 to the 23 atoms or particles of that material. Okay, it's something that we have to be able to calculate. I'm going to show you how we calculate that. It's actually very easy. So if I want to calculate the molar mass of a compound, I can't just look that up on the periodic table, right? I can look up the molar mass of atoms on the periodic table, but I can't look up the molar mass of compounds because it's not listed. So if I want to calculate the molar mass of water, okay, how many hydrogens are there in water? 2. Okay, and every hydrogen is, well, sorry, the molar mass or atomic mass of hydrogen is 1.01 on yours. Rounded off on yours. Okay, so the molar mass of hydrogen is 1.01 grams per mole, and there's how many hydrogens here? 2. All right, so I just go 2 times 1.01, okay, grams per mole, and then I add that to the molar mass of oxygen, which on your periodic table is 16. Okay, there's only 1 oxygen here, so we got 2 times 1.01, which is 2.02, plus 16 is 18.02 grams per mole. So what that's telling me is that if I had 6.02 times 10 to the 23 water molecules, I would have 18.02 grams of water. Okay, that's about 18 milliliters of water. Okay, not very much. It's about fit in like the cap of a bottle cap. It's not a very large amount. Okay, it's very nice. Like what, a teaspoon? A teaspoon is 15 milliliters, something like that. Okay, so it's not a lot. Okay, it's very, very small.
So you just take so when you calculated every element in the compound, figure out the molar mass and add them together.
And add them together. And that's how you do it. Yeah, that gives you the molar mass. So to get the molar mass of a compound, you take the molar masses of all the elements and you add them together, keeping in mind that you may have to multiply if you've got the little numbers in there. Okay, not difficult after all. Okay, let's have you guys try a few of those. Okay, so you'll need your periodic tables here. Sure, good. Okay, I shouldn't hear that much talking, guys. I should just hear pencils scratching on paper. Doing this right. Okay, so number one, we got sodium chloride. How many sodiums are there? Just one. All right, so we go 22.99, and then we add on to that one chlorine, which is 35.45. Okay, it's going to give us 50.44? 58.44, right? Okay, so... What? You never seen that before? It's my calculator. I'm old, so I have to have a big one. I can see it. Okay, so 58.44. And what are my units here?
Grams per mole.
Grams per mole, right, because this is the number of grams in 1 mole. Okay. All right, for number 2, we've got iron with bromine. There's only one iron, so 55.85 plus 3 times 79.90. You guys are easily impressed. Okay, 295.55. Grams per mole. It's called the TI-83 emulator. Actually, there is an app for it on your phone, but you have to use the code for your calculator. You have to actually have a TI-83. Otherwise, no one would buy one. Okay, for number 3 here, okay, we've got diphosphorus pentoxide. Right, so we got to put in 2 phosphorus, so that's 2 times 30.97 plus 5 times 16. Soon you too will have memorized the periodic table and will know all of these numbers. No, you probably won't. And you don't have to. Okay? I don't know them all. I just know the common ones. Okay, so 2 times 30.97 plus 5 times 16. All right, so we're looking at 141.94 grams per mole. Now, the question came up here a minute ago. How do I calculate the molar mass of a polyatomic ion? And the answer is the same as you did for these compounds. You got to do it element by element. So in number 4, there are 2 nitrogens and 8 hydrogens. All right, I'm going to give you a few more minutes to get those last 2 done. Okay, so for number 4 here, we've got ammonium sulfate. Okay, and we have to do this piece by piece. So I've got 2 nitrogens, so that'll be 2 times 14.01 plus 8 hydrogens, so 8.08. Okay, 8 times 1.01. And then add to that a sulfur, so that's 32.07 or 32.06. 07, and there's only 1 sulfur, and then there's 4 oxygens, so plus 16 times 4. Okay. All right. Everybody with me on that? Okay. So we put those together here. So we've got 28.02 plus 8.08 plus 32.07 plus 64.
Times.
Yeah, which is 64. Okay, so we got 132.17 grams per mole. Okay, so this is a pretty important skill, but it's a pretty basic skill. Okay, you're not going to be able to do mole equation calculations without being able to calculate molar mass. It's like not being able to write chemical reactions without being able to write chemical formulas. Okay, one skill depends on the other. Right, so being able to do this, excuse me, is pretty important. Okay, then we have scandium carbonate. This is 44.96. 44.96. Okay, times 2, because there are 2 of them. Okay, and then we've got 3 carbonates. So that's going to be 12.01 times 3, because there'll be 3 carbons. And there'll be 9 oxygens. Okay, so we got 44.96 times 2 plus 12.01 times 3 plus 16 times. All right, so looking at 269.95 grams per mole. Sorry, someone asked a question?
Well, I got 269.9, not 5, but 6.
Oh my god.
Yeah, I'm gonna redo it.
You must have typed one thing in wrong. Something pretty small.
Or you just like completely.
Okay, everybody all right with how to calculate molar masses?
So we need molar mass to calculate.
Yeah, molar mass is part of the mole equation.
Okay, that's we use it for. Yeah. So it makes sense now.
I'm not blind, that's why glasses.
Okay, so when we're looking at chemical reactions, okay, when we balance the chemical reactions, we can interpret those balanced reactions to mean a couple of things. In this reaction here, this reaction really could be one nitrogen molecule reacting with 3 hydrogen molecules to form 2 molecules of nitrogen trihydride. Would I even notice that reaction? No, it's an incredibly small amount of everything. So really what we're saying when we balance these is these are ratios. 1 mole of this requires 3 moles of this and will produce 2 moles of that. Okay? And then when you get into Chem 20, you'll actually use this in something we call stoichiometry, which is using the mole equation applied to an entire reaction. You can use it to calculate if I had this many moles of nitrogen, how many grams of this would I need? Okay? Or how many grams of this would I produce as a result? Okay? It's not hard. I know it sounds like it's really hard, but it's not. Okay? Because you know the mass of your reactants has to what? Your products. Equal it. Right? So if you can figure out what's on the product side, you know it's equal on the other. Okay? So it's really not as hard as it kind of leads on to. Okay. So we can look at it in terms of particles, like we said, 1 molecule, 3 molecules, 2 molecules, okay? Or we can say, oh, that's Avogadro. He looks like a mole.
He does.
Yeah. Like even his eyes. His eyes
are massive.
But it's the cut of the suit that makes him look like he has no shoulders. And moles don't really have big shoulders because they have to put them.
I was thinking like
Okay, the other way to look at a reaction, okay, is the number of moles. Okay, and obviously we can do like grams or whatever. Okay, so we can do mass as well. We can look at it in terms of mass. As long as we remember that I'm going to have that these balancing coefficients are really telling me a ratio. Okay, the mole equation. N equals little m over big M. Because in chemistry, we can't think of other letters to use. There are 26 letters in the English language, and we're going to use M twice in the same 3-variable formula, and the only other letter we're going to use sounds like M. Because that's how chemistry works. Okay? All right. So here's what we have to know. What does each part of this stand for? All right, well, N is the number of moles. Okay, so N stands for the number of moles. Little m is the mass of the material, and that will be in grams. Okay, obviously moles is going to be in moles. Okay, and then big M is the molar mass, that thing we just learned how to calculate. Okay, and that will obviously be in grams per mole. Okay, so that's what the three parts of that formula stand for. Yeah.
Where go on my rant?
Okay. Now, somewhere along the way, I'm sure, some well-meaning teacher taught you that this is a mathematical okay? I know who it is, okay? I'm just not going to, I'm only partially calling them out here, okay? So, this is crap. There's no nice way to say it, guys. This does not help you. This does not help you learn how to manipulate equations. The other problem with the triangle is it stops working after you have a certain arrangement of variables, like if you have more than 3. Okay? It doesn't work after that. So we're not going to use triangles at all because triangles are a crutch. Okay? You use crutches while you're hurt and learning to walk again, like Austin is. Okay? But it'll only work for so long. You don't want to be on crutches for your whole life. So I'm the guy who's going to kick the crutches out and make you walk. Okay? Austin, I'm going to let you stay on the crutches for a little while longer again. Okay? All right. So here's what you need to know. Okay? First off, point number 1, triangles suck. Okay? Triangles suck, they don't work. Here's what. This is a formula that you will use in this course that a triangle won't work for. Okay? You will use that formula in the physics unit. A triangle cannot do any operation other than multiplication and division. This has multiplication, division, and subtraction in it. So it won't work. Okay? You get to physics 20.
I don't have it.
I'm pretty sure there's no triangle for that. I'm pretty sure, like, not even like a rhombus or anything. Okay? It's going to work for that. So this whole thing about plugging formulas into shapes so that you don't have to do math, that's done. Okay? Because here's the thing, guys. Unfortunately for you, you guys were part of what was euphemistically known as the new math. Okay? Yeah. And it was a failed experiment. Okay? It really was. Okay? And yeah, it was. Okay? Teachers everywhere said, hey, this is not good. It's not going to work out well. Nobody listened to us. And unfortunately, for 6 years, we had to teach it. And, well, actually not us, luckily. It was mostly elementary school teachers who were forced to do it. And there was massive outcry because teachers know how to teach, and teachers knew it wasn't going to work. Okay? Finally, somebody listened because parents started getting annoyed that their kids couldn't do it. Okay? And the problem that we always had with it is teaching kids tricks to do math inherently tells them 2 things. Math is hard, and you can't be good at it. And that's not the message we want to send. Okay? And unfortunately, that's a very common message. Probably a lot of us think that. I even think that. Okay? I often think, I'm not all that good at math. I can do algebra. I can do math. I can do some multiplication in my head. I can't do, like, calculus. If I was looking at the stuff you're taking in Math 10, I would probably struggle. Okay? It's been a long time since I did that. But I can figure it out. The thing is that inherently, people are naturally good at math. At least simple math. Okay, I'm not going to say everybody's going to be good at differential calculus. That's true. Okay, I wasn't. Okay, but everybody can be good at least for basic math, being able to do algebra and manipulate equations. It isn't that hard. Right? So what I'm going to do is I'm going to teach you the 3 rules of algebra. You only need to know 3 rules, and you'll be able to get through basically anything. These 3 rules got me through university physics. Okay? Just knowing 3 rules. So rule number 1, okay, for manipulating equations. If you want to move a variable, you perform the opposite operation. So if I am multiplying it, I would divide to move it over to the other side. If I'm adding it, I would subtract. Simple rule. Okay. Second rule. Short way of saying that, what you do to one side, you do to the other. Okay? But if I subtract something from one side of the equation, I also have to subtract it from the other to balance. Okay? Okay? And the third rule, and it won't even apply to this formula, okay? Isolating. When you're trying to isolate a variable, okay, that is, get something by itself and solve for it, move what's not attached to it first. Now I'm going to show you what I mean by that, because when I say it, it doesn't always make a lot of sense. Okay? So here's a formula you're going to use both in this course and in Math 10 this year. Okay? It's the formula for a linear progression on a graph. Okay? Y equals m times x plus b. Okay? If I want to get m by itself, following these 3 rules, I should move what's not attached to m first. So what's not attached to m on this side? B. All right, how would I move b over to the other side following these rules? I would subtract it. Okay, so I'm going to subtract b from this side. B minus b, b is gone. All right, y minus b. So I did that now to both sides. Okay, that equals m times x. I want to get m by itself, so what do I do with the x? Divide by it. I do the opposite. Okay, so I divide this side by x. X divided by x is 1. M times 1 is m. Good, x is gone. Now I do that to the other side. Now I've isolated for m. Okay? All I had to do is remember 3 rules. To manipulate the mole equation, you only have to remember the first 2, because nothing's attached to anything in this formula. Okay? There's only 3 variables. So, right now, the formula is set up to solve for number of moles. What if I want to solve for mass? What should I move?
Little m.
Nope, little m is mass.
Oh.
I want to move big M. Sorry, I should have said that. Okay, so little m is mass. I want to solve for little m. So I just multiply both sides by big M. Right? And I'm done. Here's the really good news about this formula. You will never use it to solve for big M. Why? Molar mass is always on the periodic table. So you'll never actually have to manipulate this formula to solve for big M. That's the only manipulation of this formula you ever have to do. Okay? Not too tough. Now, if I did want to solve for big M, I would move it over here and then do what with this? That wasn't very hard. Okay? That's the wonder of the smart boards. I can just do that. Okay? All right, everyone kind of follow me there. Algebra is not so intimidating. Okay? It's really not. Okay? By the time you get to physics 20, you'll be manipulating this formula with ease. dW minus just like that. Yeah. Or this one.
Yeah. Let's put there. We get it.
Yeah, you'll get there. You'll get there. No problem. Okay. All right. The point of it is, guys, is that people get really intimidated by math, and it's not that bad. Especially the math that you're going to have to do in science. Okay? The extent of the math you have to do in science is really just being able to manipulate an equation to solve for something other than what it's originally set up for. Okay? That's it. That's all you'll have to do. Okay. There are only 4 ways I can ask you a mole equation problem. This is the easiest way. I'm going to go over all 4 ways every day for the next 4 days. But I won't get through all 4 today. Okay? So Monday, Tuesday, Wednesday, I will go over an example of each way that I can ask a mole equation problem. So that by the time the unit exam comes, I will have gone over 12 different examples of how to solve a mole equation problem. Since there's only 4 ways I can ask it, and only 3 mole equation questions on the test, will you have seen all the ways I could possibly ask it? Multiple times. Okay? All right, write this one down. Okay, so in this question, and anytime I'm solving a problem in science, the first thing I want to do is write down my givens. That is, what numbers does the question tell me? Okay, so right now the question tells me that I have 90 grams of calcium chloride. What part of the mole equation is the 90 grams? It's a little m, right? It's the mass. 90 grams. What does the formula CaCl2 help me get? Molar mass. Yeah, helps me get big M. Okay, so I've got calcium chloride, so that'll be 40.08 plus 35.45 times 2, which is 110.98.
Yeah.
Yes. Yeah, it is. Yeah. Okay. Okay. 35 times 2 is 70. 45 times 2 is 90. 70.90. And I just added this on. 110. 70 plus 100. Right? Plus 40. 110. Add 408.
You might get it.
No, I don't need to have a math contest with anybody.
I should have met our math teacher at St. Francis.
What's that?
Our math teacher at St. Francis.
Yeah.
It's insane. You do like 125 times like 1.48 like in his head in like seconds, and then beat right.
That's impressive.
Yeah.
I was awful. Because he would show you up, and then he'd be like, show you
You use your calculator and just telling it to you.
I like that. Okay, so I've got these 2 things, and the question wants me to calculate the number of moles, which is N. So I don't even have to manipulate the formula on this one. It's already set up to solve for number of moles, and I have the 2 parts that I need. Okay, so all I have to do is plug in the numbers, 90 for little m and 110.98 for big M. Okay, Okay, so if we're looking at units here, I've got grams on the top, grams per mole on the bottom. What am I going to be left with for units? Moles, which is good because that's what we're solving for. Okay, it's a way to kind of confirm if you manipulated something correctly. We didn't manipulate this, so it better be set up to get the right answer. Okay, all right, so 90 divided by 110.98. Okay, so it's telling me I have less than a mole. Is that okay?
Yeah.
Yeah, sure it is. That's still lots. Okay, it's 0.81 moles. What's that? No, I abbreviated. Mole is moles. Yeah.
So it's MO.
MOL. Yeah. Well, the general rule is yes to the 100th. The real rule is use what we call significant digits. The only number I had the least accurate number that I was given had 2 measured values. So my answer can have 2 measured values. But in general, we can only go to 2 decimal places. All right. Questions on how that one worked? Are you all right with that one?
Yes.
Okay. Here's the second way I can ask a molar equation question. All right, so this one says, what's the mass? So it's asking me to find what? Little m. Okay, of 4.5 moles, so it gave me N, of magnesium bromide. Okay, now, this is the way I would give you one of these questions. I'd give you the name in words. Because then you have to get the right formula. If you don't write the formula right, are you going to get this question right? No. It's pretty important, that whole being able to write formulas thing. I think I said that once or twice before. Okay, so we've got magnesium bromide here. So we got 24.31 plus 79.9 times 2, right? I'm right on the magnesium. Right? Yeah. Okay, so 184.11 grams per mole. Okay, so I have N and I have big M, and I'm looking for little m. So if I want to get little m by itself, I'm going to multiply both sides by big M, and then I'm going to plug in my numbers. So that'll be 184.11 grams per mole times the number of moles, 4.5. Okay, the moles will cancel and I'll be left with grams. Okay, so I'm going to have 828.50 grams of this stuff. Okay. I'm not going to get through the last one, so I'm just going to ask you this, because it relates to the next one. In that 4.5 moles, how many molecules of magnesium bromide are there? Yes, you are going to have to use Avogadro's number, right, to figure that out. So, how would I use that? What is Avogadro's number representing it? The number of particles in 1 mole. I have 4.5 moles. What do I do with those two numbers? Multiply them. Exactly. If somebody asked you, you have 4 dozen donuts, how many donuts do you have? You would automatically go 4 times 12. It's the same here. You have 4.5 moles, 4.5 times Avogadro's number, and you've got the number of moles. Sorry, the number of molecules. Okay?